number 16. Now we're going to graph 4 lines and shade either above, below, left, or right. And then we're going to look for the common shaded region. Now, these two we could knock out pretty easily. X must be greater than or equal to 0. Y must be greater than or equal to 0. Basically means we're looking to the right of the y-axis and above the x-axis. Okay? So it's basically limiting us to quadrant 1. Okay? These are all out. So that's it. I've already graphed 2 of the 4. The other 2 would be 3x plus 3y less than or equal to 42 is one of them. And I would graph this with what's called the 2-intercept method, or the cover-up method, which perhaps we mentioned back in October or September. You could graph it with slope and y-intercept if you want to try to get y by itself, but I think that's a waste of time. The 2-intercept method is plug in 0 for x, find what y would be, plug in 0 for y, and find out what x is. Once I have the 2 intercepts, I can connect them with a line, and voila, I'm done. I have a line, right? It's called the cover-up method because you can technically cover up like this. Okay? If 0 goes in for x, it basically covers this up, right? And if 3y was 42, what does y have to be? 3 times what is 42? 14. So that's the y-intercept, 0, 14. If 3y equaled 42, then y would equal 14. Okay? The other one, blank comma 0, well, in that case, you're plugging in 0 for y. Basically covers this up. And if 3y equaled 42, what would x, if 3x equals 42, what would x be? So let's put 2 dots at 0, 14 and 14, 0 and connect them with a line. Solid line because it's less than or equal to. If it didn't have the equal to, you'd make a dashed line. So it's going to be a solid line connecting these two. So that's the blue graph. Let's do the green one. And why don't we do the cover-up method once again? I didn't shade yet. We'll get to the shading in a minute. All right? Let's do the green one. If I covered up y, that didn't work very well. If I covered up y, what would x equal? It says less than or equal to. Pretend it's just equal. What's x? So 18, 0 is the x-intercept. Okay? If I covered up x, what would y have to be to make 2 times something equal 18? 9. Okay? So 0, 9 is the y-intercept. 18, 0 is the x-intercept. Connect them. Now both of these say less than. So normally that means you shade below. I think it's going to work. But you can always double check by using a test point, like 0, 0. If I plug in 0 and 0, is 0 plus 0, is 0 plus 0 less than 42? Yes, then that's the way you shade, towards the star. What if you put 0 and 0 in there? Is 0 plus 0 less than 18? Yes, then that's the way you shade for the green. We're limited to quadrant 1 only, So I think the shaded region, the double shaded region, would be right here. That would be the solution area. Any point that you pick in that black spray painted area would be a solution to all four inequalities. Right? Pick any point in there. How about 4, 4? Yes? 4, 4? Pick the point 4, 4. Is y bigger than 0? Is 4 greater than 0? Yes. Is 4 greater than 0, my x? Is 3 times 4 plus 3 times 4 smaller than 42? 12 plus 12, smaller than 42? Yes. Is 4 plus 2 times 4, 8? Is 4 plus 8 smaller than 18? Yes, because it's in the solution region. Anything in there will make all four true. So on a multiple choice test, you could pick a point and test it in all four, and then that should be the one that works, right? And this